Hello everybody, and welcome to a new Submer webinar. This time we're going to talk about circular economic models, sustainability, e-waste in the data center industry, and its impact on the environment. This is a topic that's very dear to us here at Submer. One of our core values is respect for the environment and trying to design solutions that are innovative and sustainable. We all know the importance of technology. Technology is what drives humanity forward, solving problems and creating opportunity, but it also creates environmental and social challenges that can't be ignored. And we have to be conscious of the massive streams of e-waste that we're generating. And circular economic models are poised to deliver major advances that offer true immediate solutions. And today we have with us a real expert on circular economy. But just before that, let me briefly introduce myself. So I'm Daniel Pope, as many of you know, and I'll be your host for this session. I'm Submer's CEO and co-founder together with Paul Valls, and my background is in data center design and operations, where at a very young age of 16, I started my first data center business literally in my bedroom. In all those years, I was lucky enough to see some major technological achievements such as virtualization and the evolution towards a resilient software stack in the data center. Together with Paul, we decided to create Submer back in 2015, a deep tech company where our ambition is to transform traditional data centers into smart, lights out, immersion cooled data warehouses driven by robotics. Immersion cooling being just the first piece of the puzzle in those next generation infrastructures. And as a matter of fact, there was this really nice article published just last week about the so-called post-human data center, which is written by John Edwards. I would really recommend it. And if you search on Google, how to plan today for tomorrow's lights out data center, you're definitely going to have a great read. If you want to get in touch, don't hesitate to reach out to me by phone, email, Twitter, LinkedIn, whatever. This webinar will be available on our YouTube channel, where you can also find all our previous webinars. And please follow us on social media to remain updated about Submer's news. You can now also find us on Applecast, Spotify, Simplecast, SoundCloud. I think every single platform that's out there, we're on it. Regarding Q&A, we will be reserving 10 to 15 minutes at the end of the session, together with our PR and communications manager, Matteo Mezzanotte, who's also here with us. And we'll address as many of your questions as possible. Please type your questions into the QA section in Zoom. Without further ado, I am delighted to introduce you to Ali Fenn, our esteemed special guest for this session. Ali oversees all revenue channels at ITRenew and leads strategy for the company's circular data center initiatives, including principally the development of modeling, analytics platforms, new business and market development. Ali has been building enterprise and cloud technology companies for 20+ years, and previous to ITRenew was the CEO of Impact Atlas, a real-time analytics SaaS platform in the global development sector. Prior to that, Ali led worldwide market development for cloud systems and solutions at Seagate, and held executive leadership positions at Wise Technology, Bear Systems, and several SaaS companies in the enterprise space. Ali holds an economics degree from Yale and an EMPA from London School of Economics. Ali, welcome. Anything else you'd like to add? I was told you love Spain, so I hope once COVID allows, you can visit us here in Barcelona soon.
I do. Thank you for having me, and I definitely wish that I was there in person back in Barcelona.
Yeah, so the stage is yours. Please go ahead.
Terrific. Well, Danny, thank you so much for having me. I appreciate the chance to be here. Talk about a subject that is definitely near and dear to my heart personally. We are, as has been discussed, we're going to be talking about what I see as both the opportunity and truly an imperative for us to think about and evolve to more circular economic models in the tech sector. And the reason why is because we are operating collectively, all of us, at unprecedented scale and in the sector, and technology enables everything that we think about and do today in our personal lives, professional lives, and so forth, especially more so even now. That scale has the potential to have massive impact, both positive and negative. And we think circular economic models are a really important piece of the puzzle as we seek to capitalize on the positive potential and minimize the negative potential. So just, you know, some basic context on circular economic models that will hope to give people the right framework to think about this as we go into the session. In the traditional kind of model that the world has operated in for decades now, we think of it as very linear, right? So we take resources, we make things with those resources, and then we too often dispose of them. And recycling is actually disposing as well, right? So it's better than landfill, but it's still disposing, right? We think of things as having sort of singular use cases, right? We you know, since probably the middle of the last century have moved towards what is truly too much of a disposable and consumption-driven economic model. And that model has proved to put us in a place where we are really depleting the Earth's resources in a way that's unsustainable, right? It turns out that it's also the model that doesn't maximize the financial value of resources and things, and we'll talk about that. But so it's super important opportunity now to be thinking about how do we move towards a more circular model, and that's what we're going to talk about today. I'm going to first set some context for kind of that scale and the potential, both positive and negative, that I mentioned at the beginning. And then we're going to focus on the data center industry as a subset of the technology industry, where, you know, we have some really interesting research that we've done to talk about and to characterize the data and the potential, and because it's happening now, right? It's a good sort of mini case study as to how we can think about moving towards more circular models more holistically across the tech sector. Very quickly, first, who's ITRenew? We are in this business, right? We operationalize and orchestrate circular data center models and circular economic IT models. We work with most of the major hyperscale cloud companies to help them think about how they maximize lifetime value of assets, how they think about lifecycle management. We physically decommission equipment from those environments, and then we create secondary markets for all of this equipment, which, as you'll learn more, is the circular model, right? We're creating secondary lives, in some cases tertiary lives. And as we do that, we're maximizing both the financial value of assets, IT assets, but also the sustainability value. And, you know, our belief is that to do the right thing to maximize financial value, to maximize the positive potential of technology, is not in conflict with what maximizes the sustainability value, right? It's a core part of our mission to say we want to believe, we want to foster growth in the tech sector, we want to unleash the potential of it at scale in all the best ways, and none of that should be in conflict with doing the right thing from an environmental perspective. So let's just dive in. Scale. IDC says that the global IT hardware industry, IT industry is about $5.2 trillion in 2020. The hardware portion of that, devices and infrastructure, is over $1 trillion, 1.2. That's the 5.2 number is the largest industry in the world, right? For context, and this is very positive context, it's bigger, for example, than the global oil and gas industry, which is about 3.3 trillion, right? So the good news is we are spending money on technology, and we are investing in technology for a variety of very positive use cases, which is, again, at a scale which is almost hard to fathom, right? other ways of looking at this, right? There are about 13 billion connected devices now in 2020. And the expectation from markets and research and Grandview research is that that number goes to 75 billion over the next 5 years. So again, average of about 10 devices per person globally. If you think about that at scale in all corners of the world, it's an immense amount of devices that are connecting over the internet and generating a tremendous amount of data that feeds, again, very positive potential, but requires a tremendous amount of resources to deliver, right? Same time, those devices and we all and our applications, everything that we do professionally, personally, and so forth, is expected to generate about 520 zettabytes of data by 2025. It's super hard for people to understand what a zettabyte is. So I wanted to share my favorite stat, which is that some people are estimating that a zettabyte, a single zettabyte, is the equivalent amount of information to all of the grades of sand in all of the world's beaches globally, right? So again, impossible to fathom the beaches around Barcelona, the beaches everywhere around the world. Take that and multiply it by 520, and that's the amount of data in terms of information that we're going to process and do something with in the next 5 years. So again, just driving almost unfathomable demand for infrastructure, both hardware and software. And of course, we're going to focus on hardware today because that's the stuff that consumes the physical materials. But it's obviously a massive amount of information that's driving all of this. Now, from a positive potential perspective, all of this investment in technology enables massively interesting things, right? It enables everything that we see in healthcare, especially we're seeing telehealth now. It enables everything we see in, whether it's from smart manufacturing, autonomous vehicles, space travel, climate science, you name it, right? We as an industry, people operating in the cloud sector, people operating in the various application sector, we have the ability to harness technology to do amazing things, right? I mean, people talk about superhuman computing in the not too distant future, right? Immense potential. And the question I often pose though is, we talk a lot about clouds, are our heads in the clouds, right? At what cost is all of this phenomenal investment in technology? And that's where we're going to talk today about how we can potentially turn these things into less costly and more impactful. Couple stats here. Just to showcase again the potential, sort of the imperative really behind this. We generate about 50 million tons of e-waste every year as an industry. To put that in context, that's if you stacked like 18-wheel trucks front to back from New York to Bangkok and back, full of e-waste every year. That number is growing. People are talking about the fact that we need to start mining the deep sea beds for the minerals that are going to make up electronics, because we're going to completely deplete all of the land-based sources for those minerals within the next 10 to 15 years. We're using a tremendous amount of energy, right? There's an estimate that says we're going to consume more power in the tech sector than full energy produced by 2040. Things like AI are, again, incredibly powerful tools, but come at a big cost, right? So there's another forecast that within the next few years, AI alone could amount for as much as 10% or more of the global energy demands. And as a sector, the most alarming stat, and the stat that I think should compel all of us to really think about how we work together to change some of the practices and become more sustainable, is that as an industry, digital industry, we are on track to go from about 4% of the world's greenhouse gases to as much as 8% in the not too distant future, right? And what that basically means is that as the global community is working really hard to decrease emissions and to work towards the climate change principles of 2 degrees and 4 degrees and so forth, as an industry, we're going the wrong direction, right? We're going from a relatively lesser to a more high percent. And that just tells me we've got to work together to try to think about how we drive innovation differently than we have in the past. The last piece about this is really a humanitarian piece. And the question I would pose is, all of those immense power and positive potential of the tech sector, is it really distributed evenly, right? And it turns out that still, we're getting better. A few years ago, it was half the world's population is not online. The most recent stat this year is about 41% is not online. So we are getting better, which is very interesting. Unfortunately, there's a tremendous amount of e-waste still that goes to, not coincidentally, the same places in the world where the population is not online. So we have kind of a 1-2 punch of some of the developing countries are still hindered by lack of access to infrastructure, lack of access to technology, and populations that are not online and therefore not generating as much economic growth, prosperity, and so forth. But we're also then shipping back a bunch of e-waste, right? So there's sort of a compounding problem in parts of the world that is problematic to all of us, not just in various parts of the world, right? And there's an estimate here from the World Bank about 6 or 9 months ago that says if we were able to get the populations in some of these countries that are still developing online to the tune of like 75%, that could generate as much as another $2 trillion US dollars equivalent of economic impact, right? So massive potential to kind of lift the overall global community. And frankly, COVID-19 has exacerbated this kind of unequal distribution of technology and the impact of not having people online, right? If you think about not just economic potential, but what happens if people can't get telehealth? What happens if they can't do online education? What happens if they can't work remotely, right? So anyway, not only an environmental impact, but absolutely a social impact that is tied to and touched by this situation of kind of pervasive technology and the scale that we're all operating at, right? One more point on this for context setting. It's not just me talking about it, right? The UN set out in 2015 some sustainable development goals, and there are a couple that are directly related to this topic, right? The first one is industry, innovation, and infrastructure. This is about that context we just talked about, which is getting people online matters. It's important. It feeds not only the elimination of poverty, which is goal number 1, but it feeds access to education and equal rights and prosperity and so forth, right? Healthcare, everything else. The point that's most important about here is that there's another estimate that says we're about $100 billion shy of the budget required to achieve that universal access goal, which means that the traditional ways of us delivering infrastructure are insufficient. We have to innovate here in order to drive goal number 9 and to get people online, connected, and so forth. At the same time, there's another one which is very straightforward: responsible consumption and production, right? We cannot keep trashing the planet. We're gonna run out of resources. Circular economic models would say, hey, let's not just do this kind of single-use disposable world that we live in. Let's actually truly maximize the financial value and the sustainability value of all of the materials. Goes hand in hand with this, right? So this is circular economy kind of 101, right? So let's look at it in practice. In a circular economic model, rather than that linear model, the goal is keep assets in their highest utility value as long as possible, which means that you have this kind of notion of cascading of assets into lesser value situations for as long as possible, wherein recycling and any sort of waste stream is the least worst alternative, right? So the first thing you want to do is, in looking at the data center industry as an example that we're going to dive into here, is say, okay, what if I have racks of equipment, right? I don't want to just recycle those when I'm done with them. I want to actually take those racks and give them a second life as racks. That's the least kind of transformation. It's the least energy input and so forth. If I can't do that, maybe I can turn those same compute and storage resources into things like edge solutions. So in other words, not rack scale, requires a little bit more transformation, but you don't jump all the way to recycling. Same thing in between kind of edge solutions or other remanufactured type, so, form factors. You can think about recertifying and reselling components, right? So we're keeping as much as possible out of the landfill and going through these loops of recertification, remanufacture, reuse as long as possible. And as we do that, we're deferring a tremendous amount of new manufacturing, which we'll talk about in a minute, has a very significant carbon impact in addition to just the sheer materials. So that's context. We'll come back to a little bit more of the data center examples in a minute, but some more stats, right? When we talk about e-waste of 50 million metric tons, that's a global stat. in the data center industry, the important stat is servers, right? So these are Gartner numbers that says in data centers that have an average of over 50 servers, 50 racks of servers in them, there are about 65 million servers deployed in 2019. There's about 14 million servers expected to go into those places over the next 4 years. And so you should land at about 120 million servers deployed in the world in these data centers. But unfortunately, what's true is that you end this period of 2023 with 75 million servers. So what that tells you is that there's about 46 million that are coming out over that same amount of time, which again is just a tremendous amount of physical material that's entering the waste stream if we don't do something different with it. So we have this mass challenge, and then we have an energy challenge, right? And the good news is, on the energy challenge side, we are doing a fantastic job, right? You see companies from Microsoft to Google to Iron Mountain to everybody doing a very good job thinking about use phase energy, thinking about deploying green grids, renewable sources of energy and so forth, which is fantastic, right? This is all essential. Nobody can keep that. We have to keep our foot on the gas here, right? Everything that goes into better energy usage. Cooling is a great example, right? We have to make these data centers much, much more efficient. Submer is obviously playing an important role in this. But the question then is, if we're looking just at renewable energies as the solution to the environmental challenges of the data center industry, are we looking at the whole thing? And it turns out that there's some other really important pieces, right? So energy really hits the use phase, right? When I turn on the racks in a data center, what is the cost of that from a power perspective, financially, and an environmental perspective? And the greener the grids we are, the better we are at efficient cooling. This is essential stuff, right? But we did an analysis recently, late last year, that helps to give us a view of where should we look next, right? If we assume success on continuing to drive PUE with all of this, the energy use phase, innovation, where do we look next? And it turns out that if you look at the process of kind of everything that goes into pre-use, right? So mining of materials, manufacture of components, assembly of systems and racks, transportation, and all of that, everything that happens before you get to a data center, that's the pre-use phase, that's part of embodied energy. The other part of embodied energy is everything that happens post-use. So end-of-life practices that involve generally sorting of materials, shredding, smelting, and so forth, right? We did a full life cycle analysis of kind of standard x86-based data center racks, and it turns out the embodied content really, really, really matters, right? So we're doing a pretty good job, as I said, on the use phase stuff. We've driven PUE down immensely in the majority of data centers. We're continuing to do those things. But if 3/4 of the carbon impact of IT equipment is associated with everything that happens before you ever turn it on, then that gives us a really good place to say, what if we could defer that process? What if we could defer that new manufacturing, right? And what deferring that new manufacturing means is, what if we could enable a second life for that equipment, right? Can I buy myself, can I use that same equipment and defer that whole 76%? It turns out that it has a really meaningful impact, right? Because if you think about the fact that 76% of the total carbon impact, the net CO2 equivalent impact, is associated with the pre-use phase, that embodied content, which is shown in the green bar here, then if you decrease that, what happens if you buy a second life is you decrease that portion a lot. Now, you do absolutely have a slightly higher impact to operational cost and carbon because equipment is running longer, but it's far more than offset, right? So the net impact is about 25% when you move to a circular model as compared to when you're in a linear model, right? And that's all associated with deferring the new manufacturing. Now, to just put that in context, that same increase from a net CO2 perspective is the equivalent of saying I'm going to get 68% better in my use phase energy, right? So, think about what that means from PUE gains. Think about what that means from other efficiency gains in the data center. That's a big ask, right? We've already squeezed a lot out of the use phase energy. So to get another 60, 70% is a big ask. So this is, a pretty good way of achieving the similar kind of a gain. Now, one of the obvious questions is, well, but wait a minute, you know, does it cost me more, right? I get it from a sustainability perspective. That sounds really good. But are we living in like, you know, 2015, 2010, where, you know, to do the right thing from a sustainability perspective actually carried a cost and you had to pay more to do the right thing? And the answer is thankfully no, right? If you run these models out and you model out the changes in Moore's law, you model out hardware depreciation, you model out the cost of power, all of these things, utilization in data centers, it turns out that the overall system TCO, which is, again, just the deferral of new manufacturing, is also about 25% better. So significant gains shared by both kind of first life deployment, like the hyperscalers in this case, and second life consumers of the recertified circular equipment, right? So we have a nice opportunity here, which is truly a win-win, which is, hey, I'm going to get the maximal sustainability benefit and I'm going to get better TCO, right? From a waste perspective, also super important. If we just theorize that we could make those 46 million outbound servers that I talked about before, if we could buy them a second life, that would be the equivalent of about over 30 million metric tons of carbon, right? So how big is that? It's almost 7 million cars coming off the road every year. That's an annual number, right? So it's a massive amount of carbon impact that could come just from deferring the new manufacturing of racks in data centers, right? So sounds like a pretty good win. The question is, what does it look like? What does it take to do it? Well, thankfully, open technology, open source hardware, open source software has been really taking the world by storm for the last 5 to 10 years, more on the software side. And that gives us the platform, right? So ITRenew is in the business of doing this recertification of equipment, hyperscale equipment. It's enabled first and foremost by open technology. So super, very important. The open compute community, super important to this. The ODM integration model, super important to this. Our relationships with hyperscalers and the fact that hyperscalers are decommissioning this equipment at massive, massive scale, also really important because that predictability, that availability, the openness gives us the ability to say, okay, these solutions, we can now turn that stuff into solutions that are useful, usable, and accessible by the broader downstream markets. And here's the clincher is that the downstream markets get radically better economics as well, right? So this is what catalyzes and unblocks some of those budget constraints, whether it's the universal access budget constraint or whether it's the fact that if you're a global enterprise, a telco, a tier 2 or 3 cloud service provider, you don't have the budget latitude that a Facebook or a Google or a Microsoft has. You actually have some real constraints. And because we can give you recertified equipment, then you can get it at significantly lower cost than you would get with a proprietary traditional OEM model, right? So suddenly we have the ability to bring things to the markets at scale, predictably, with really significant economics. And the key is, well, again, at what cost, right? Do I have to compromise something, right? And the critical success factor for any circular economic model is it can't be without compromise, right? Everybody on this call, everybody we engage with knows that, like, to do the right thing from a sustainability perspective, for most of human nature, it can't be any more inconvenient, right? It can't come with compromises. It can't be more, it can't require me to do a whole bunch of other stuff, right? It has to be just as easy. And in this case, what that means is no compromise to performance and to quality, and you just focus on outcomes per dollar, right? So if recertified equipment, I can just plug it in, it meets the needs of my use cases, whether that's, you know, Kubernetes, VMware, you know, whatever, OpenShift, or whether that's virtual desktop environments or machine learning environments, whether that's converged environments. If I can just plug this equipment in, and I don't need to worry about, oh, gee, does it not quite give me the right performance or so forth. But if I can match the performance needs of my workload and I get the best outcomes per dollar, then why would I not do that, right? So this is the opportunity we have to do it today, to use the data center industry as a really great example of what is the success recipe for moving towards more circular economic models across the IT industry in general, right? And I would just summarize by saying, you know, again, to the comment I made at the beginning, and I'd love to get into the full detail of this with anybody and everybody at any time, because you can probably tell I'm passionate about it. We didn't talk much about the financial opportunity here, but we've modeled that we think there's about a $50 billion hyperscale value recovery opportunity here, right? So what that means is that the upstream partners of ITRenew, people like Facebook, like Microsoft, like Google, and others, are motivated to also drive this circular economic model, right? Not only are they driving to carbon negative, not only are they driving to renewables, they have a real financial incentive in addition to a sustainability incentive to help these models succeed. And on the so then it's like, okay, I got upstream incentive. Then on the downstream side, the financial modeling that we've done says that there's probably about a $10 billion a year market for recertified hardware in this fashion, right? So you get kind of a nice matching right hand, left hand of, I have motivation on the upstream side, I have motivation on the downstream side of people who are like, hey, I need my budget to go further. If I don't have to give anything up in terms of quality or performance, I'd absolutely like to get that 50% TCO advantage, right? And then of course, we talked about the sustainability impact, potentially really, really significant from a carbon perspective, and the human impact, which is, what if we could take this 50% TCO advantage of hardware and unleash that 40% of the people that are still not online, unleash that $2 trillion of GDP, but do it in a really sustainable way. So we're not continuing to kind of trash those same environments that we're seeking to benefit, but we can actually really strive to drive the global community towards these sustainable development goals. Then, this feels to me like not just a win-win from a financial perspective, but truly a win-win-win, where we've got kind of both the financial benefit, the sustainability benefit, and the human and social benefit that I think the global community is seeking to achieve, as evidenced in the Sustainable Development Goals. So I'm going to leave it there. Daniel, I'd love to engage in whatever questions, but hopefully this gives people a little taste of the kinds of things we spend our time on and the kind of opportunity we think exists tied to circular economic models in the tech space.
Thank you, Ali. It's super interesting. We have quite a few questions. I actually took some notes here. So first, I'll kick off with my one probably. But so hyperscale hardware, OCP, is designed to be more efficient than traditional server manufacturer equipment, let's say. And that's something that you're already delivering, I guess, to the non-hyperscale customer. Which means that you're actually getting more efficient systems and standards into organizations that probably in the past haven't evaluated that opportunity. I guess also, how do you see the willingness to adopt a different standard and form factor from the industry?
Yeah, it's a great question. In fact, the people who are familiar with the open compute community, the OCP community, one of the things that we talk a lot about is that this is also a key tactic in making OCP and that hyperscale model available to all, right? It's interesting that the hyperscalers have unique opportunity associated with the thousands and thousands of engineers they have, and the fact that they don't need anything that the traditional OEMs supplied, right? They don't need software certifications. They don't need somebody to design the systems. They don't need support and warranty. So they've been able to really move towards this open and ODM model that is now supplied by ODMs like WeWin and Quanta and others, right? But unfortunately, they've been so good at it that they have rendered those businesses like 2 and 3% margin businesses that can't then provide the full kind of solutions that the global markets need, right? Everybody else in the world needs things like support. They need VMware certification. They need integration of converged nodes. They need rack level appliances that you can plug and play and that you don't have to have 10,000 engineers to integrate and support, right? And so there has been this gap in this kind of unequal distribution of the hyperscalers being able to further accelerate their advantage in that more efficient architecture and the more efficient systems and so forth. They've been able to run with that where the rest of the world has been able to see it and be attracted to it, but not really capitalize on it, right? Because they haven't been able to get those same solutions. We do see this as a key tactic in saying, okay, let's bring that same stuff, the hyperscale technology advantage, the TCO advantage that's just part and parcel of the architecture. Let's turn that into solutions that are then accessible, useful, usable for the rest of the markets by giving them what they need, bringing it to market with warranty, with support, and so forth, and at very disruptive economics, right? So we absolutely see that this is a way to bridge that gap and get more people to have access to it. And when we talk about 50% TCO advantage, it's two layers, right? The first part of the layer is you're getting that TCO benefit that the hyperscalers have already taken advantage of, right? It's much more, it's rack level power, it's more efficient cooling, it's all this stuff. It's much greater density, but then it's also the pure CapEx cost on top of it, right? So it's right to think that people have not been able to move to it en masse as much as the hyperscalers. We see this as a key bridge. The other piece of this is there's a bit of a myth around, oh, wait a minute, that stuff requires a radically different data center infrastructure, which is just not true, right? Actually, the difference between a 19-inch rack and a 21-inch rack is exactly the same. It has not to do with the outside dimensions, the external dimensions, only the inside dimensions, right? That's the density play. You can fit more in if you utilize 21 inches of the inside space, not 19. And power, right? You can still, in fact, we do a lot of this kind of power transformation to make sure that whatever the power infrastructure you've got, if you're in a colo, you're in your own facility, wherever it is, these racks can still play in that space. So I think part of what we need to do is, continue the education around the fact that, we often say nobody's electrons are too weird for us, right? like you can make this stuff work in any traditional environment, and then of course you can benefit. Depending on that environment, you benefit more or less from the inherent architectural advantage, but it's accessible to all, right?
Thank you, Ali. We have a question also from Astrid Wine. Hello, I'm interested in the 76% embodied energy figure. Is this for all servers, Dell, HP, etc.? Is this for one particular part of the world? Does it assume success on renewables, etc.? The reason I'm asking is that other LCAs put the proportion a lot lower.
Yeah,
and a comment, I'd love to use this figure, by the way.
Yeah. It's a fantastic question. And so the analysis that we did, this is actually, it's actually incredibly difficult to do a full LCA lifecycle analysis on a rack of equipment because there are many, many different manufacturers involved in that process, and many of them, for various reasons, are not motivated to share all the data about exactly what goes into manufacture of those systems. But we did, as part of our analysis, we leveraged about 60 probably industry and academic data sets and journal articles, published articles, and research into this analysis, and as well as our own data, which, because we decommission all of this equipment, we have very specific and exact information about the mass balance of all of the equipment, right? And then we have to make some assumptions about where things are manufactured, how they're manufactured, and so forth. And then we did, as part of our analysis, because it's so difficult and it draws on so many different sources of information, we did also run an independent third-party validation with the ThinkStep organization, which does this as their business, right, and manages the most extensive global data set. It is very much an open OCP style rack, right? This is not specific to the proprietary OEM equipment like Dell or HPE. We don't have access to that information, but it's similar, right? Think about x86 racks and it's generally in the right ballpark. So from a hardware perspective, I think it probably is analogous to an OEM model. What is key is the other part of your question, which is that the grid mix is the most significant lever in the entire analysis, right? So the 76 number comes from a pretty common use case of mine materials in the places that they're found. A lot of that's done in Africa and so forth. Manufacture components in China, assemble systems in Eastern Europe, in the Czech Republic specifically, and then deploy those systems in Sweden in a data center, right? So this is a very typical kind of a model that we see many of the hyperscalers operating under. If you look at deploying a data center, doing manufacturing, for example, in Mexico and running a data center in Montreal, the number is actually 96, right? Because it's complete hydropower in Montreal and Quebec. And so the operational phase energy is significantly lower, and it's all about the manufacturing use phase. However, if you look at a place that's a little dirtier grid, such as Virginia in the United States, those numbers do invert, right? So you're actually, you're hitting on the most critical point of this, which is that in Virginia, it's more like 70% use phase and 30% pre-use phase. And this is why, you know, the starting thesis here is we must assume success on renewables. We must continue that quest. We must make our data centers more efficient, because that's table stakes. But the next question is, where do we go from there, right? Because that alone is not enough. But it is in the life cycle analysis, that lever of grid mix is the single most important driver.
Awesome. And what do you think is the percentage of equipment coming from hyperscale versus equipment deployed in hyperscale versus equipment that's non-hyperscale? Because I guess that's quite a relevant figure there.
In terms of that 46 million server number that's outbound?
Yeah.
I mean, the reality is, the hyperscalers don't publish anything about the specifics about their fleets. Everybody, I think there's general, you know, surmising going on that says these guys are all running many millions of servers in their fleets. So you can make assumptions if they're generally operating at a roughly 3-year refresh cycle about what portion of that is theirs. The more significant portion of that 46 million is stuff that's been deployed longer in more traditional enterprise environments. But I think the interesting thing is to look at the mix going forward, right? So enterprise makes up about 50% as compared to cloud currently in terms of data center infrastructure deployed. And within the cloud, the hyperscales are more than 50%, right? So it's a very significant amount. The hyperscale stuff is unique in its ability to be recertified and made circular because it's open, and because we have access to it at massive scale. Whereas to kind of roll up a bunch of these outbound enterprise smaller scale data centers is more challenging. And the OEM stuff is more challenging to recertify because it's proprietary by nature, right? So it's much harder to do the transformation on and to support downstream in the markets. I think what's most interesting about that stat is to say, you know, and I didn't include a growth stat in here, but infrastructure is exploding, right? So it's directionally interesting in terms of, hey, this is massive amounts of equipment, and to the extent that things are moving more open, we have the ability to harness a lot more of it, regardless of where it comes from, right? And we should be doing that.
Absolutely, we absolutely should. How about things like open firmware, for example? I guess it facilitates enabling the reuse of those servers, I would expect. So when you have to repurpose one of these nodes, having access to open hardware and open software, I guess, facilitates that whole process, as you mentioned, versus the proprietary systems.
Absolutely, it absolutely does. It's a key initiative. Open systems firmware, both BIOS and BMC work. Increasingly also people's approaches to secure boot, which becomes more and more important going forward. So yeah, the work that's happening on Linux boot, on Open BMC, things like Open Titan, the fact that the OCP community has instituted a requirement that for systems to be OCP certified by March of next year, 2021, they have to come with open systems firmware. These are all really important movements in the industry. And this is where, you know, I think there's a shared kind of mindset and ethos that needs to happen. And then it needs to fuel the collective will and the technology underneath it to make this stuff really happen at scale. Now, what happens in the short term is, you know, a company like ITRenew has to obviously do a lot of work on things like Linux boot and Open BMC. We're involved actively in all that in those communities, but as in advance of those things becoming ready for full prime time at massive scale across all platforms, we also have to still support traditional firmware. But to the extent we can move towards more open systems firmware across the board, it's infinitely better for circular economy. It's also infinitely better for security, right? So I think there will be a lot more tailwinds behind this stuff, but it's a key piece for sure.
What's the challenge behind educating your customers, your end customers, that a 2-year or a 3-year used node coming from a hyperscaler still has a much longer lifespan available on it? And you can compare it to a lot of the traditional hardware in a telco being run for up to 10 years, for example, right? What's that challenge like, Ali?
Yeah, it's interesting. It's one of our key challenges from a go-to-market perspective, clearly, and we see a range of responses to this topic, right? As you suggest, lots of people are very accustomed. Very big, large-scale data center environment customers are accustomed to running things for 6, 8, 10 years. So this is not surprising to them, right? The hyperscalers refresh stuff very quickly for very good reasons. But that doesn't mean it's aligned to the technology treadmills, and other people are much more accustomed to those longer term life cycles. So in that vein, people are not surprised in some ways. On the other hand, we still have certain customers, anybody who's generally buying new equipment, are not the people who are accustomed to managing that equipment for 10 years, right? Those are different parts of an organization. So you have an architect who's accustomed to saying, I want the latest and greatest this or that. And it is a new mindset and a new conversation for them in some cases. Thankfully, what we're seeing, and I think this is a key piece to having this kind of succeed at scale, is that the cloud, the public cloud, has really proven out a model that says, you know what, I care about performance per dollar. I care about outcomes. I don't care about what part number is in that box, right? I care about a number of containers, a number of IOPS, a number of teraflops, a number of cores, whatever my net metric is for my workload. That's what I ultimately care about. And ultimately, it's about how many users can I serve, how many jobs can I process, you know, it's some amount of outcome. And I want that at the most effective dollar, and I want it to be easy. And so we're thankfully going to benefit, I think, from the riding the wake of that public cloud value proposition, which is, why shouldn't private cloud be just as easy, right? Why shouldn't I just get to turn it on and have a similar amount of cores, memory, storage, whatever it is, and deliver the same outcomes at the best possible cost and not have to worry about the rest of it? So we talk a lot about, like, what's the right envelope of conversation? And frankly, if people are in the weeds and they're fixated on part numbers and so forth, there are some use cases where that is absolutely the right thing. But the significant majority, I don't know if it's 80% or what the number is, but there's a large majority for whom that's not the right conversation. And the right conversation is wait a minute, what is the outcome I'm trying to achieve, and how do I do it most cost effectively? And so I think we're benefiting from the fact that that's the conversation that you have when you sign up for AWS or Google Cloud or Azure or something else. And now you just want a near cloud experience that's pretty much the same. And that's going to help, right? It's going to help with some of those conversations.
Absolutely. It absolutely will. I'm going to take one last question for the sake of time. So ITRenew and OCP are just two examples of change of tendency in the whole industry. What is still necessary to do?
Great question. You know, I think it comes back a little bit to what we, you know, sort of the theme of this conversation, which is awareness and commitment, right? We have to change our mindset in the same way that we have to change our mindset to, you know, reusable water bottles, right? We have to get away from thinking about things as disposable and commit to the fact that, hey, the onus is on us to prove that quality, performance, and so forth is there, whether that's in buying a certified pre-owned BMW, whether that's buying a recertified Sesame rack, whether that's buying, you know, not asking my local pub not to have plastic straws, right? We have to have a changed mindset about this. And And the onus is on us, companies like ITRenew, to bring the evidence to say you don't have to give anything up to do it, because that's the only way it's going to happen. But ultimately, we need everybody to get on board with the fact that this is the right thing to do, right? It's the right thing to do, and it's in our collective interest to do. And I think, honestly, I think, you know, that's why I love to come and have these conversations, is I think the more that we get the conversation going and have people say, why won't it work, right? What's going to fail? What does it take? These are all the important conversations, right? For everybody.
Absolutely. And educating and really showcasing that these systems still have a long lifespan after being used for a couple of years is absolutely key. Thank you so much, Ali, for joining us today. It's been a great presentation. Once again, if you want to be updated about Submer's news, we suggest to subscribe to our YouTube channel and follow us on social media. And I would also like to remind you about our ebooks. The first one I wrote, which is the 3 W's of immersion cooling, but we've released a whole new series entitled The 5 Pillars to Build a Smart Data Center. And we obviously refer to circular economy of IT equipment in those. So thank you very much for your time, everyone, and we'll see you soon in one of our upcoming webinars.
Thank you so much for having me, Daniel. I really appreciate it. It's great to have the conversation. And thank you, everybody.
Ali.